Alright guys, really quick, we're going to do a quick video on percent composition on how to find all three of them. Just really quick, just so I could show you guys. I know you guys were having problems, so let us get to it. I am going to do a simple compound just because I do not, at least at the present moment, do not have my periodic table. And hydrogen, we all know that that is going to be the molecular weight of just 1, while chlorine has a molecular weight of 35.5, if I'm not mistaken. So let us first draw out the hydrogen. So we're going to have hydrogen and chlorine. So hydrogen is going to be only 1, because you only have 1, and the molecular weight is that of just 1.0. Chlorine, on the other hand, is also just 1, but the weight is going to be that of 35.5. Now, whenever we get the answers of individualized elements, hydrogen would be that of 1 times 1, being that of just 1. And 35.5 times 1 is going to be 35.5. When we add these guys up, remember we do not have a mass, so we will be using molar mass, being that of 1 plus 35.5, making us have 36.5. So now we are going to try to find the mass percent of each individual element. So the first one we're going to do is hydrogen. So percent of hydrogen equals that of the mass of the element that goes on top. So we get this one and we got put it over here. In the bottom you will put the molar mass, being that of 36.5. You will also need to multiply by 100%, so your answer could be in percentage. Our final answer should be that of 2.7% for hydrogen. Now let us see chlorine. So mass percent of chlorine, instead of having 1 on top, you're going to have that of this number, 35.5, because that is a mass of one individual chlorine atom, or rather the chlorine atoms within that compound. And in the bottom we will have the molar mass, being that of 36.5. You are also need to multiply 100%, so our answer could be in a percentage format. So 35, you're going to do in your calculator 35.5 divided by 36.5 times 100, which should give you that of 97.3%. Our numbers together should equal that of 100% at the end. The next step, or the next question, would typically be in a word equation format, but I don't have enough space here on my pad for me to write the actual whole question, so let me just read a question for you. Imagine you do have 36.4 grams of nitrogen trioxide, and you only have 14 grams of nitrogen. Now, mind you, if you do have this of the compound, the NO3 together as 36.4, you will need to then subtract with 14 so you can get your answer for oxygen. So 36.4 minus 14 would relatively give you that of 22.4 grams for oxygen 3. Now, do you really need to find the or use a periodic table? Typically no, because you should have already the grams of what you have here. So for nitrogen, the percent for nitrogen would be just the mass of the element, which is out of 14.0 grams, and in the bottom is going to be the total mass of the compound, so that'd be 36.4 grams. Remember, the bottom is going to be that of the compound. Also, do not forget to put the percent, the 100%, because your answer should be in percentage. So 14 divided by 36.4 times 100 should give you an answer of 38.5 grams, or rather percent, my bad, percent for nitrogen. Next is to find the percent of oxygen. So in oxygen, you do have that of 22.4. Remember, that O3 portion doesn't really necessarily matter because you already are given grams. So you will be messing only with grams. You're not going to be using the periodic table for this. So here the answer is going to be that of 22.4 divided by 36.4 times 100, which should give you an answer of 61.5% of oxygen. Now 61.5 plus 38.5 should give you that of 100%. Okay? Now remember, in these type of situations, either you could subtract, just like in this situation here, the compound with the element that is given, the grams of course, or I could have given you the grams of nitrogen and the grams of oxygen to create the compound. So you would have to therefore add 14 and 22.4 to give you the mass of the compound. So please be careful with that, okay guys? Alright guys, so really quick, because I don't really have much time on this free trial, I am going to do this really quickly, and as I am explaining, I am going to be writing at the same time, so please catch up. Now I know a lot of people had problems with this, so I am going to explain it right now really quick. The first thing you need to do is get that of hydrogen by itself, sulfur, and oxygen, as if you were trying to do the mass percent for, or percent composition for each individual element. For hydrogen, we do have 2, and the molecular weight is that of 1. Now 1 times 2 is obviously going to be that of 2. Sulfur, on the other hand, you only have 1, but the molecular weight is that of 32.1. So 32.1 times 1 is obviously 32.1. And then lastly, we have oxygen being that at 4, and the molecular weight is that of 16.0. Now 16.0 times 4, I'm pretty sure we should already know that this is going to be that of 64.0. When we add all of these guys up, our answer should be that of 32.1 plus 2 plus 64, equaling that about of 98.1. Now we are going to have to find out basically the percentages of each individual element first. So the percent of hydrogen equals that of the element on top, so that is going to be 2.0, over the molar mass, which is 98.1, times 100%. Our answer should be that of 2 divided by 98.1 of times 100, I forgot about that, is going to be that of 2.0% of hydrogen. Next is that of the percent of sulfur, which is that of 32.1 divided by the molar mass times 100% equals, so let's see, 32.1 divided by 98.1 times 100 she'll give us that of 32.7% of sulfur. And then the last one is that of percent composition of oxygen. Oxygen on top is going to be that of 64.0, 98.1 times 100%. So this should give us 64 divided by 98.1 times 100 should give us that of 65.2% of oxygen. I know you guys cannot see it, but I did write oxygen on the side. So 65.2 plus 32.7 plus 2 does equal that of closely, roughly about 99.9%, which I said it wasn't that bad. I would typically, for me, I would check off the numbers real carefully. So yeah. Now let us do the second portion. Alright, so we're going to continue on with the question prior to what we basically just did, where we already found basically the percent of hydrogen, sulfur, and oxygen within the compound of sulfuric acid. Now, what does this number have to do with any of this? This is what you're going to do. You're going to grab the number that you start off with, which is 90. That is the number I give you. So let us first deal with hydrogen. So you're going to do 90.0 grams times, and then the line, dimensional analysis. Now, because hydrogen has a 2%, you're just going to change it to 2.0. You're not going to put any units, at least for now, okay? So don't worry much about units yet. So you're going to put 2.0, and in the bottom you're going to put it into 100%, or just basically 100 grams. So you could say, in a sense, this is also grams, but for hydrogen, okay? The grams will represent that of sulfuric acid, the same for the 90.0 grams. Now, if we make the math carefully, it is going to be that of 90 times 2 divided by 100, which should give you an answer of 1.8 grams of hydrogen within sulfuric acid. Next, you just repeat for the other ones. So 90.0 grams of sulfuric acid times, then the line, then we have on top 32.7 grams of sulfur over 100 grams, because we are again assuming we do have 100 grams of this compound. So that it is 90 times 32.7 divided by 100. Your answer should be that of 29.4. So 29.4 grams of sulfur. The last one is 90.0 grams times, then the line. We do again have 100 grams in the bottom, but now we're going to get the percentage of oxygen, which is 65.2 grams of oxygen, equals, so our answer is going to be 90 times 65.2 divided by 100, which should be 58.7 grams of oxygen. If we add them up, it should relatively be the same as 90, but let us just make sure. 58.7 plus 29.4 plus 1.8, which gives us again a close amount range of 89.9 grams. My bad, that was supposed to be a 9. There you go. 9 grams of H2SO4. That is basically how you do those two questions that you guys were more than likely having problems with. If you have any further questions, please let me know, and I'm hoping you guys actually liked this last minute video. Alright, see you in the next time. Bye guys.